Hello everyone. In this session, I'm going to tell you about the Hadoop fundamentals, HDFS and YARN architecture, HDFS high availability definition and architecture, and in the end, I'm going to show you a demonstration about Hadoop version 2 cluster build. So what is big data? Big data means lots of data in terabytes or petabytes. Big data is the term for a collection of datasets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. So the challenges can be capturing of the data or curing of it or storing that data, sharing it, analyzing it, visualizing it. So there can be many challenges around big data. Now, Hadoop is a platform for structuring that big data. Existing tools or traditional tools, they were not designed to handle such large amount of data. So Apache Hadoop is a project which develops open source softwares for reliable, scalable, and distributed computing. Apache Hadoop is a framework that processes big data on clusters of commodity hardware with a vibrant open source community, and it has got many products and tools that reside on top of Hadoop as well. So the most recent version of Hadoop is 2.7.1. Hadoop version is also continuing to be developed, which is available as release 1.2.x. Now, some of those features in the newer version of Hadoop 2.7.1 are high availability with manual and automatic failover, which means you can always have a highly available cluster with both the administration daemons of name node and resource manager. You can have a rolling upgrade, which means you can upgrade your entire Hadoop cluster without bringing any down, without getting any downtime of the cluster. Hadoop on Windows, which means you can always install or configure Hadoop cluster on Windows machines. And yet another resource negotiator, which is basically a newer version of MapReduce, or I would say it's a newer framework that addresses the shortcoming of MapReduce version 1. So we'll talk about all these, about YARN and Hadoop distributed file system in the upcoming slides. So what is HDFS? Now HDFS appears as a single disk in the Hadoop cluster. It runs on top of a native file system of Linux, and it is based upon the Google's file system, which has got both fault tolerance, which can handle disk crashes or machine crashes, and it's it stores large files. So HDFS is good for storing large files like in the terabytes, petabytes of data, or 100 megabytes or more per file, or millions of files rather than billions of files. And there's no need for supercomputers. In fact, use less reliable commodity hardware. So HDFS has got two components, name node and data node. Name node manages the file system's namespace and metadata and file blocks, and it runs on one machine to several machines. Data node stores and retrieves data blocks. It reports to name node and runs on many machines. It has also got third node, which is called secondary name node, which performs housekeeping work. So name node does not have to. It requires similar hardware as name node machine, but it is not used for high availability, and it is not a backup for the name node. The next we'll talk about the YARN. YARN consists of two important daemons, which is called resource manager and the node manager. So as I said earlier, that YARN addresses the shortcomings of MapReduce version 1. So YARN has actually, the job tracker part of the MapReduce version 1 has been split into two daemons. One is called resource manager, which administers resources on the cluster, and application master, which manages the applications such as MapReduce. So YARN provides a fine-grained memory management model where application master requests resources by asking for containers with a certain memory limit, like 2 gigabytes, 3 gigabytes, 4 gigabytes. And YARN administers these containers and enforces memory usage. And each application job has control of how much memory to request for any mapper or reducer task. So YARN has got two daemons. As I said earlier, one is called node manager, which is installed on per node in the cluster, on each slave node in the cluster, which manages the resources of that single node. There is one instance per node in this cluster, in the cluster. Resource manager, it manages the resources for a cluster. So it instructs node manager to allocate the resources, and application negotiates for resources with resource manager. There is only one instance of resource manager per cluster. Apart from this, we have got another daemon which is called history server, MapReduce history server, which basically archives the jobs metrics and metadata. It is a MapReduce specific daemon. So let's talk about how the job is executed on Yarn. First of all, client submits the MapReduce job by interacting with the job objects. Here the client is running in its own JVM. Then the job code interacts with the resource manager to acquire the application metadata such as application ID. After that, the jobs code moves all the job related resources to Hadoop distributed file system to make them available for the rest of the job. So in this case, you can see all the job code has moved all the job related resources to the Hadoop distributed file system here. Job code is then submits the applications to the resource manager. After that, resource manager chooses one node manager with available resources and requests a container for MapReduce application master. Node manager then allocates a container for the MapReduce application master, and MapReduce application master now will execute and coordinate the MapReduce job. So MapReduce application master grabs the required resources from the Hadoop distributed file system, such as input splits of the data. These resources were copied there earlier from the client node to the HDFS. After that, MapReduce application master negotiates with the resource manager for available resources. So here it connects to the resource manager first. It requests for the resources from the resource manager, and again the resource manager selects one node manager to start a map and reduce task here. So node manager will create a yarn child container that will coordinate and run this task. Yarn child container again will acquire the job resources from Hadoop distributed file system that will be required to execute map and reduce tasks. Yarn child will then execute map and reduce task in its own container. Once the job is being finished, the client will poll for the status from the MapReduce application master and take the output of the job. Now we'll talk about the high availability definition and the architecture. So high availability is a system design approach and associated service implementation that ensures a pre-arranged level of operational activity in the Hadoop cluster. So the idea behind the high availability in the Hadoop cluster is that the cluster should not go down if the name node is down. The cluster should not be down if the name node is down. So in this case, high availability feature single point of failure can be overcome. So in this case, we have got lots of daemons here, as you can see in the picture, that helps in bringing this, in having this high availability architecture. So first of all, as you can see, we have got a couple of data nodes that are talking to both the name nodes in the cluster. So there will be an active name node and a standby name node. By having this block information with both the name nodes, it helps the standby name node failing over back to active name node, failing over back as active name node very quickly. So there is another set of daemon which is called journal node. It's a lightweight daemon which can run on the separate node, or it can also run along with the name. So the active name node writes all the metadata in these journal nodes, and the standby name node reads all that metadata and applies that metadata into its own node. To control that failover, there is group of separate daemons called active zookeeper failover controller and standby zookeeper failover controller. These failover controllers, zookeeper failover controllers, monitor the liveness and health and manages the high availability state. So they store all their information, all their session metadata inside this zookeeper service. So once the active name node is down, this active zookeeper failover controller changes that metadata inside this zookeeper service, which this standby zookeeper failover controller is reading, and it comes to know that the active name node is down. So it makes the standby name node and switch it to the active state. So in this case, the advantage here is that zookeeper failover controller helps in making the standby name node as active name, because as I said earlier that all the data nodes are advertising their blocks to both the name nodes. So in this case, the failover is very quick and there is no hindrance on the jobs or any kind of a session blockage for any kind of a jobs in the cluster. So this is the entire high availability architecture, which has got, which can be having more information about the zookeeper services, what kind of information it stores, as well as how about these general nodes, how you will build those nodes in the detailed session. So now in the end, we are going to talk about the Hadoop cluster modes, and we are also going to see how we can build a Hadoop 2 cluster. So we can have three kind of a cluster modes in the Hadoop cluster. First is called local or standalone mode, which does not have any kind of a HDFS, or it does not have any kind of a Hadoop daemon as well. So everything runs in the single JVM. Then we have got pseudo distributed mode, which is used for the development purposes. In this case, entire Hadoop cluster runs on a single node, where you will have all the Hadoop processes or Hadoop daemons running in that single node itself, along with the Hadoop distributed file system. So this is basically used for the development purposes. After that, we have got the fully distributed mode, which is used for the debugging purposes and runs in production as well. So basically all the Hadoop processes run on a different nodes. So we are going to talk about the fully distributed mode in this demonstration here. So right now my design is to have a 4-node cluster in which I have got these 4 hostnames and IP addresses. These are the IP addresses of these nodes. I've created couple of roles for each node. Like I've got name node role for first host, resource manager and history server for the second node, data node, node manager and the secondary name node on the third host, and data node and node manager on the fourth host. All these are running as a virtual machines at the backend, and each virtual machine has got a hardware configuration of 30 gigabytes hard disk drive and 2 gigabytes RAM each. You can always increase the hard disk drive and decrease the amount of RAM for each of these VM. That depends upon your laptop memory or desktop memory. You can always increase and decrease the memory and hard disk according to your capacity of your server or your laptop if you're practicing on your laptop or desktop. So the prerequisites of building this Hadoop cluster is to download the Hadoop from the below link and to download the JDK from the below link as well. So you need both Hadoop compressed tar file as well as JDK compressed tar file to complete this Hadoop build. So if you see here, I've got this name node. This is my name node here, on which I've got both the Hadoop 2.7.1 tarball, and I have extracted it and just moved it into the Hadoop folder. Similarly, I've got the JDK tarball and I have extracted it and moved it into the JDK folder. The same contents I have got on all these nodes. So I've got the same actual contents, on all these 4 hosts on the cluster. So the next step to build the cluster is to edit the configuration files. So first of all, I will edit the core site.xml. The core site.xml is basically used by the Hadoop cluster for input output within the HDFS. So if you see, these are all the XML files, and these XML files has got a start tag and an end tag. So every tag has got a start tag, and this is the end tag. Again, this is start tag, end tag, start tag, end tag. So this is the format which is being used by these XML files. So every file has got couple of properties. This core site.xml has got couple of properties which is being used by the HDFS for the IO key. So for the IO, if you want to write the data or read the data, you need to always connect with this URI for that. So the next thing is, these are a couple of properties that I have mentioned in this core site.xml. The next step is to mention the HDFS site.xml. In this file, I'm going to provide my replication factor, which means how many times a block is going to get replicated in the nodes, in the data nodes. And also I have mentioned on which node the secondary name node is running. The next step is to mention about the mapred site.xml. This mapred site.xml is basically being used by the cluster to let it know that we are going to use the Yarn framework for the MapReduce. As Yarn framework is a very generic framework, which means it can not only run the MapReduce program, but it can also run the Spark programs, HBase programs. It can also run the OpenMPI graph programs. So it's a very generic framework that helps in running multiple frameworks on the same cluster. So here I am seeing MapReduce framework name here is Yarn. So Yarn will be helping us to execute the MapReduce jobs. Along with it, I need to edit the yarn site.xml. Yarn site.xml is basically required for yarn specific daemon settings, like where my node manager is, node resource manager is, and where will be the application master. So I'm going to edit all those configurations here in this case. And the last thing is, I just need to edit the slaves file. In the slaves file, I'm going to tell on which all nodes my data nodes will run. So here I'm providing the IP addresses of both these hosts. On both these hosts, I'm going to run the data nodes. The last configuration that I need to edit here is that Java home. So here I'm going to tell where the Java home will be. So Java is a must for Hadoop cluster group. After that, I just need to copy this entire configuration on multiple nodes, on all the nodes basically. Once this is done, I just need to format my name node. So by formatting, what does it mean? Formatting means creating a storage directory for the name nodes metadata, and this directory will be holding all the name nodes metadata here. So once it is successfully formatted, it will give us a information message saying that storage directory /home/hadoop/data/dfs/name has been successfully formatted as I have highlighted here. Once this is done, you just need to start your Hadoop daemons. With the command start dfs.sh, it will start the name node, two data nodes, and one secondary name node. And then I'm going to SSH into the resource manager. From there, I'm going to start the resource manager, history server, as well as the node managers. So you can see it has started name node, data node, and secondary name node. So it is still starting. And once it is done, I'm just going to SSH into the resource manager and start the resource manager and both node managers. And I'm also going to start the history server like this. Once it is done, I'm going to run a small shell script to see what all processes now are running on my cluster. So as you can see, I've got 4 hosts. Name node is running on the name node host. History server and the resource manager is running on the resource manager host. And data node and node managers are running on the data node host along with the secondary name node. So let it come up. And we have got another host which is data node, which will have only the data node and the secondary name. Sorry, data node and the node manager. So as you can see, all these daemons have come up now and they are very much working fine. So once it is done, we'll just open a web interface to see whether, so before that we can see that it is aligning to our design. Okay, we have got these roles. We thought to have these roles earlier. We designed our roles like this on the notepad, and the same roles are being executed on each host here as well. So we can now open a browser and see whether the name node is coming fine or not. As you can see, name node web interface is coming fine, and it has got the configured capacity, DFS use and non-DFS use kind of information. You can also see the data nodes here. You can see what all data nodes are connected to this name node. You can see multiple information here with the snapshots, data node volume failures, startup progress, utilities, etc. Along with it, you can also see the resource manager web interface by running the port number 8088. So you can see there are two nodes connected to it. So if I click on the nodes, you can see two node managers are connected to this resource manager. The last thing is I can also see the web interface for the job history server. I need to just go to the port number 19888 and it will show me the job history server web user interface. Okay, so I think that's all in this session. These web interfaces will provide all the information about what's happening in the Hadoop cluster. So that's all from this session, guys. If you want to refer anything, you can just go through these links. There are two enterprise level links coming from Cloudera and Hortonworks, and we have got an open source Apache Hadoop link as well. You can refer to these links to get more information about these Hadoop daemons and Hadoop processes. So that's all from my side today. If for more information, you can reach us at info@rareskills.co, or you can always call us at this number. Thank you and have a good day.